Hello, and welcome back to the channel, where we explore everything and beyond. Over the past episodes, we've been assembling our Tryton web client layer by layer. We started with communication, then authentication, menus, layouts, UI components, the data model. Each step added structure and responsibility. Today, we close the final chapter of this series by focusing on dynamic values. So far, we've built the framework. Dynamic values are what allow that framework to react. They make the interface responsive to context, enforce rules defined on the server, and compute results without hard-coding logic into the UI. In Tryton, dynamic values serve two primary roles. The first is controlling field states. A field is not permanently visible, read-only, or required. Its state depends on conditions: the value of another field, the current user, the record status, or the execution context. When those conditions change, the field state changes with them. The second role is computing field values. Some values are entered manually. Others are derived. A unit price can depend on a selected product. A total can depend on quantity and taxes. Instead of being typed directly, these values are calculated based on other data. To support this behavior, Tryton relies on four core concepts. The first is Python statement and object notation. Python is an expression language used to describe dynamic behavior declaratively. Instead of assigning static values in a view definition, we define expressions. At runtime, those expressions are evaluated to determine the actual state or value. Python is not limited to the client. When used in view states such as invisible or read-only, Python is typically evaluated by the client. When used in domains or other server-side logic, it is evaluated by the server. It is a shared expression language understood by both sides, ensuring consistent behavior across the system. The second concept is default values. When a user creates a new record, the client does not calculate defaults locally. It sends a request to the server asking for the default values for that model in the current context. The server executes the relevant business logic and returns the computed defaults. The client merges those values into the new record and applies any corresponding view states. This reflects Tryton's architecture. Business logic lives on the server. The client manages presentation, state, and interaction, but it does not embed core business rules. The third and fourth concepts are onChange and onChangeWith. These mechanisms are triggered when a user modifies a field configured for onChange behavior. The flow is straightforward. First, the client detects the field change. Second, it sends the relevant data to the server via RPC. Third, the server executes the associated onChange method. Fourth, the server returns updated values. And lastly, the client merges those values into the record. For example, selecting a product in a sales order may update the unit price. Changing the quantity may update totals. Taxes may be recalculated. This differs from Python-based behavior. Python expressions for view states can often be evaluated locally in the client. OnChange mechanisms require a server round-trip because they execute business logic. Only fields explicitly configured with onChange or onChangeWith trigger this process. To support dynamic behavior, a Tryton web client must provide a communication and RPC layer, authentication, a dynamic menu tree, a dynamic view layout engine, UI components for all field types, a dynamic data model, Python evaluation support, integration with default values, integration with onChange mechanisms. These are the minimum architectural requirements for handling dynamic behavior correctly. Everything else, caching, localization, performance optimization, depends on your audience and deployment context. With this, we complete the series. We now have a Tryton web client built with Typescript and Vue.js that aligns with Tryton's server-centric design while remaining responsive on the client side. Thank you for watching, and I'll see you in the next one.